Hello everyone, I'm Kalpana, working as an assistant professor in SNS College of Technology. I am from Department of Artificial Intelligence and Data Science. Today we are going to discuss about binary search trees. Let's recap. So in previous session we have taken a problem statement and we have empathized it. We got some pain points. So for that pain points we ideate and I arrive a solution, that is binary search tree. Binary search tree solve that issue, and in order to maintain an ordered list, and also when we perform insertion, deletion or search operation, if you want to perform it in an efficient way, so this binary search tree is a helpful one. And the logic behind this binary search tree is, so always my left subtree values are lesser than the root node and the right subtree values are greater than the root node. So this is the principle behind our binary search tree. So these things we have discussed in previous session, and we also discussed how to search for a particular value in a binary search tree. Okay, now we'll see how insertion will happen in binary search tree. So my root node is 50. I want to insert number 95 into this binary search tree. So how can I perform this insertion? So just remember the principle of binary search tree. So if the value is less than the root node, we have to traverse in left side, that is left subtree. If it is greater than the root node, the value is greater than the root node, we have to traverse in the right side of the root node. So that is the principle. So we apply the principle here also. So I am going to insert number 95 into this tree. So first compare 95 with the root node. My root node is 50. Okay, compare 50 with 95. 95 is greater than 50. Obviously, I have to take which direction? Right direction. I have to traverse in the right subtree. Then see the right subtree. The node is 75. Compare this 95 with 75. 95 is greater than 75. So just go to the right side of 75. You have 85. Okay, 85, then compare 85 with 95. 95 is greater than 85. So what I can do? I can place 95 to the right of the 85. So like this I have to place my 95. Okay, each time I have to compare the root node and I have to see whether I got my value or not. If not, I have to check whether it is less than or greater than. If it is greater than, I have to traverse and place it in the right direction of the node, or else I have to place it in the left subtree. Okay, this is the principle of the binary search tree insertion. So next is it's just a thinking exercise. Let's do it. So we need to locate number 15 in this tree. Okay, this is a binary search tree. So we have to locate number 15 in this tree. So how can we do this? So first begin with the root node. My root node is 25. 25 is compared with what? 15. 15 is less than 25. So which direction I have to take? Yes, left direction I have to take. So again compare this 15 with 20. Okay, it is not equal. 15 is less than 20. So I have to take the left direction, left subtree. I have to see the left node. Left node is 10. So here 10 is compared with 15. 15 is greater than 10. So I have to take right direction. So at right I am having 12. Okay, 12 is compared with 15. What happens? 15 is a greater value than 12. So I have to see in which direction. I have to traverse in which direction? Right direction of 12. So right direction of 12 is 15. Finally, I got the value. So like this I have to traverse, and if I want to insert any value or delete any value, so this is the procedure I need to follow it. comparing the value, and I have to take the decision whether I have to go in the left direction or in the right direction. Next is just designing a prototype. So it just gives you a overall idea how to create a prototype, like what can be the modules I can incorporate in that prototype. So our problem is that I have to manage a list of songs in a sorted list. So that is our criteria. That is our problem we have taken, right? So for this problem, I can have an insertion module for inserting my new songs, and I should have an removal, that is deletion module uh, to delete any particular song from the list, and I should have a search module in order to search for a particular song in the playlist. So these are all the major modules I can incorporate in my prototype when you are going to when you are going to develop an application regarding this, regarding the problem. Okay, insertion, search, and deletion. These are all the basic or the mandatory modules we need to incorporate. Next is these are all the some of the real-time applications of binary search tree. So the first is one in 3D game engines. This binary search tree is used, like to determine which object should be rendered in a 3D world. And the next thing is the compiler. Compiler uses for creating a syntax tree, and your file system uses it for file system lookup. This binary tree is used to search or look up for files in the file system, and live sorted data streaming for stock maintenance or for stock search, everything this binary search tree is used. So far we have discussed about the binary search tree. We start with the problem statement and then we empathize it. We got some pain points. So from that pain points we ideate and we arrive a solution. That binary search tree helps to resolve that problem. And we have discussed about the principles of the binary search tree. We saw the how insertion is performed, how search operation and everything is performed in binary search tree. Once again, I'll just recap how the binary search tree principle works. And here you have a root node. We will compare that root node with the search key value. If the search key value is less than the root node, obviously we have to uh, traverse our traversal continues in the left subtree. Or else if the key value is greater than the root node, then I have to continue my search in the right subtree. So likewise, we need to search or insert, or we can perform deletion operation in binary search tree. Thank you.